For my Makerspace project, I'm very proud to present an ongoing project that I've been working on for the last year or so between my job at Notion as well as the Varman School. Back in September, I created a 4 to 6 page proposal to integrate robotics and programming into an empty space in the Varman School. The goal was to use STEM in order to inspire students to explore and design on their own. And I also trained two teachers specifically in robotics in order to incorporate these types of learnings. The following is the document that I submitted back in September for the Varman School Makerspace purchase. I tried to create a variety of STEM products from K to 9, as well as a research and development program for electronics and 3D printing. The only problem with my proposal was that everything that I submitted was based in US currency. And living in Mexico, it was a little difficult to ship items down to Mexico from the US. So the first, 5 to 6 months, we were first funded starting in December, and then the first robotics purchase arrived in February. The last 6 to 8 months have been mainly exploratory, where students are just and teachers are exploring the different uses of robotics in the classroom. We have a technology class that students come to, and we've been using Dash and Dot robots in the lower grades, as well as the Arduino microcontroller in the upper grades. And the goal for this coming year is to be much more applied, where teachers, not just the technology teachers, but teachers, content area teachers, are using these robotics. And we're trying to incorporate technology in cross-disciplinary projects. Eventually, by the end of the year, being very ambitious, I would love to see students in the Varman School, as well as teachers, taking part in portfolios and displaying their own work and possibly participating in a maker fair. We started off with a grant from Tinkering, a small startup company in California, and then we moved into Dash and Dot robots. And like I said, we also use the Arduino in the upper grades. And as you can see through these photos, students are exploring their learning. It's guided using prescriptive materials. And the students are all wearing glasses, at least they should be, because I see one little boy that's not. But that's one important thing about the makerspace, is being safe. So short-term goals, like I mentioned, by the end of the first month of school, I would love to have the makerspace coordinators I am the makerspace coordinator, but the makerspace coaches that work in the makerspace to host a robotics fair, inviting all teachers, parents, and especially the administration to come see what different types of robotics we're using. And then also by April 2017, we have the third annual Jalisco Maker Fair, which is sponsored by Make. And it will be just about 2 or 3 hours outside of our town. So I would love to get a group of students organized to present there, and then possibly as well at ISTE in San Antonio during a poster session. The curriculum and content goals I tried to tie to this project were two that I found in the literacy track. It was actually surprising that I couldn't find very many in the math or the sciences. I was hoping that in the upper grades that there would be some Common Core standards that related to the makerspace. But the first one had to do with the multi-step procedure, which is the design process, carrying out experiments, taking measurements, and performing technical tasks. I would add notes to that. When you create an iterative process of design, you should take notes and understand where you went wrong each step of the process in order to make any kind of corrections, especially with coding. The second standard I found had to do with integrating technical information through words. And this, actually, I found a standard that really related to coding itself, where it's words expressed in a text with a version of information expressed visually. And when you consider coding, you write syntax in words, and it expresses that as an output, which might actually be a visual algorithm where a display or a visual diagram is displayed. So Both of these literacy standards I felt applied to the makerspace. However, I don't find the Common Core directly tied to it. Now, the goal for the process of design engineering is actually an iterative process where students shouldn't think of design as starting something and then ending something. It's not cyclical as this illustration would demonstrate. It's definitely, you can go from research to planning to improving back to imagination, then asking questions, then creating a prototype, and then testing the prototype. It's definitely not something that has to be followed in a step-by-step procedure, but the process of design itself is a lifelong learning experience where students can get used to dreaming, imagining, creating, and testing what they can imagine in order to see if it works or not and if it's useful. So that's the goal for design thinking. And the instructional technology goals are abundant. I pulled from the ISTE 2016 standards. The three that really stood out to me after looking through the standards are empowered learner, innovative designer, and technological thinker. I wish it said tinkerer, but technological thinker has a lot to do with it because students are deploying strategies for understanding and solving problems in ways that leverage technological methods to develop and test solutions. That, I think, could sum up a makerspace in just one sentence. But also the design process where students are using a variety of technologies within a process to identify, solve problems, create new, useful, or imaginative solutions. And finally, students are definitely leveraging technology to take an active role in choosing, achieving, and demonstrating competency in their learning goals. So if, for example, a student identifies an objective, something they want to create, they have to identify which is the best method or approach to solving that. They might want to create a thermometer that measures the humidity in a greenhouse, and they can easily find a sketch online and program an Arduino to do that. Or if they wanted to create a computer that simulated a game, they might think about choosing a Raspberry Pi. So students understanding the tools that they have available to them and making wise decisions in order to achieve the goals. As was noted in the following week's discussion about assessments in a makerspace, it's really difficult to assess maker learning, design. Really, it has to do with your process, how well you understand the phases of design. This is a chart that was created by IDEO and presented in the Design Thinking for Educators Toolkit. And as you can see, this process almost looks like a gradual slope where students gain interest through the discovery phase, and then they hit a wall and they realize, interpreting what they want to discover is actually challenging. So their frustration level might, pop in. And then as students start to generate ideas and refine their ideas in order to, create a solution, that's where it starts to incline again, where it gets into that making, experimenting on what the idea looks like, and then finally evolution. And what you should see through each of these phases is feedback. That's the one thing that's very difficult in a makerspace, is providing all students with feedback. And that's the one thing that's crucial. I think a lot of makerspaces don't have full-time staff that work there that can help students. It's more like a librarian that's overlooking to make sure that everything's happening in a correct order. But a makerspace, students should be receiving feedback not only from their peers, but also from an expert. And that's definitely what takes place in a design studio, where students share ideas, they put ideas up on a wall, but there's always like an expert there that you can kind of get an immediate response on whether you're on the right track or not. And so that's what I think is crucial. Finally, just to end on a famous quote by Seymour Papert, the father of instructional technologies, that the most powerful idea is the idea of powerful ideas, and always realizing that, your first iteration might not be the best, and therefore the process of design is iterative, and we always try to make it better.